Hi, I'm Gail Sokol, and on today's show, we're going to be talking about chemical leaveners.
Welcome to Baking Radio. Learn the art and science of baking with author, educator, and award-winning chef, Gail Sokol. Whether you've been baking your whole life or you're brand new to the world of baking and you're looking to build your confidence and learn new skills in the kitchen, you're in the right place. This is Baking Radio.
So on today's show, I thought we would bring up and go into more detail about chemical leaveners, what they do, and really define them and give you some tips on how to use them properly and actually get the most out of them. So what are they? Well, first of all, baked goods typically use one of three leavening agents. The first one being yeast, and this show is not about yeast, but yeast is that microscopic living organism that has to undergo fermentation, and you have to wait like an hour for the dough to double and all that, yada, yada. We're not discussing that. We're talking about the last two leavening agents, baking soda and baking powder. These are used in things like quick breads. So think date nut bread, banana bread, corn muffins, cornbread, lemon cake, also cakes, cookies, and even certain candies. So if you've ever made a nut brittle, sometimes baking soda is used to aerate that caramelized sugar so that it's not so dense when you bite into it. So these chemical leaveners are actually chemicals. They're made in the lab and they react with the other ingredients in your baked good. And with the heat of the oven, it helps those baked goods to rise. So what exactly is happening with chemical leaveners? And I think I've mentioned this before, but let's talk about it again. Chemical leaveners are like team players. And yes, I mean like a sports team. So each ingredient to me, I picture as an important team member. And they're working together to get the common goal. And that is a high quality, fabulous, delicious baked good. So chemical leaveners create leavening by producing carbon dioxide gas. It's always carbon dioxide gas. And when you mix any batter or dough, you are not even realizing it. You are folding or mixing or even whisking air into that batter or dough. So these air cells that you're actually producing by doing this, these carbon dioxide gas bubbles from our chemical leaveners are seeking them out. And they're increasing the size of these air cells. And then these air cells get stuck in the batter or dough. And then in the heat of the oven, they expand and they push up and down and sideways so that you get this incredible baked good. So without chemical leaveners, you would have a very disappointing, very dense, very heavy baked good. All right. So that being said, let's talk a little bit about kitchen chemistry, because there is a lot of kitchen chemistry with chemical leaveners. After all, they're chemicals. So there are reactions happening without you even realizing it within batters and doughs to help them rise. And they're known as neutralization reactions. And when I talk about something being neutral, I'm referring to pH. So this is a measurement of how acidic or how basic something is. And most of you have heard of pH. Water is said to be neutral, and it's given a rating, or on the scale, it's a 7. So the pH range typically goes from 0 to 14. Anything less than 7 is considered acidic, and anything above 7 is considered basic. So this neutralization reaction occurs when equal amounts of an acid are combined with equal amounts of a base. Carbon dioxide occurs when these gas bubbles form as a product of these neutralization reactions and also produce things like salt and water. So the carbon dioxide gas bubbles are the things we're interested in as bakers, and they leaven your baked good. So what do I mean by an acid? All right. An acid is any ingredient that has a pH less than 7. Frequently used acidic ingredients, and they're used all the time in baked goods. Think about it. Citrus juices, right? Orange juice, lemon juice, lime juice, grapefruit juice, vinegar, sour cream, buttermilk, and yogurt. And there's even a few surprises. Let me mention a few ingredients that I bet you didn't even know were acidic. How about brown sugar? Did you know that's acidic? Molasses is acidic. Chocolate, and even cocoa powder. And Dutch processed cocoa powder, and we've talked about this on a previous podcast, Dutch processed cocoa powder has been treated with a base so that the acidity has been neutralized. So it will not react with baking soda. So let's talk about baking soda first. How does it work? Baking soda is a chemical known as sodium bicarbonate or bicarbonate of soda. And when baking soda comes into contact with moist ingredients, it could be anything, it could be a juice, it could be milk, it could be water, and something acidic, like we mentioned before, an acidic ingredient, this neutralization reaction takes place. And the gas bubbles produced form throughout the batter or dough and push up against the batter, and the baked good is leavened and it's rising and it's beautiful. Now, too little baking soda and the baked good will not rise sufficiently. Too much baking soda and the baked good can actually have this salty, soapy taste. It's going to be an off flavor. So if you ever get that from a baked good and you were a little too generous with the baking soda, you know what happened. You really want to measure it accurately. Now, there's a general rule that for every cup of flour, which would be about 4 ounces of all-purpose flour or about 115 grams, you want to use about 1/4 of a teaspoon or 1 gram of baking soda. Now, remember, this is just a very general rule. I know recipes that don't follow this rule and they come out beautifully. So don't go by that. This is just a general rule. So for every 1 cup of flour, 1/4 teaspoon of baking soda tends to be used. All right. Again, very general. Now let's go on to the next chemical leavener, baking powder. Baking powder is actually a mixture of different leaveners, and it includes baking soda. Baking soda is already in there, and it even includes 1 or more acids. So baking powder sort of is the chemical leavener that has it all. Acidic ingredients are not necessary to have in baked goods that use baking powder. Cornstarch can even be added to baking powder because it, number one, prevents clumping, and cornstarch will also absorb any moisture, which will prevent the active ingredients in that baking powder from reacting in the package and actually forming carbon dioxide in the package before you even need it. So we don't want that to happen. So when you use baking powder and you go to the store and you buy it, it's known as double acting baking powder. Whether you noticed it or not on the label, that's what it's called. And this means you get a twofer. So it reacts twice. Once, when you mix it with liquid ingredients, you're going to get a wave of carbon dioxide gas bubbles forming. And again, you're going to get another wave of carbon dioxide when heated on the stove or in the oven. So again, 2 waves of this carbon dioxide gas bubbles will form. Think about pancake batter. You know, we've all made pancake batter. So the first time you mix your moist ingredients in with your pancake batter, the bowl of batter actually looks like it's rising. And it is, because the first wave is happening. You get this first wave of leavening and you get the carbon dioxide literally pushing up against the batter. And then you start putting the batter into the frying pan and you realize you're getting another wave of carbon dioxide because the pancake itself puffs up and rises. So there's your 2-stage rising for your double acting. And a general rule for baking powder, again, general rule, 1 cup for every 1 cup of flour, you want to use between 1 and 1/4 teaspoons of baking powder. So you're using more baking powder per cup of flour than you are baking soda. Now, I want to mention one more less commonly used leavening agent, and it is a chemical known as ammonium bicarbonate. It's used in some commercial kitchens, and it tends to be used more outside the United States. Ammonium bicarbonate should only be used for a baked good that will be relatively dry and crisp when it comes out of the oven. The reason is, you hear the word that's in ammonium bicarbonate, ammonia. So it can actually retain an ammonia smell and taste if that particular baked good is not thoroughly baked to a crisp quality at the end. It's got to be really, really crisp, or you're going to end up with this weird ammonia taste and flavor, and you really don't want that. Now, this is just a little like weird piece of knowledge. I don't know how I know this, but originally ammonium bicarbonate was made from the antlers, ground up antlers of reindeer. I can't make that up. That is like so wild, right? So crazy. So the last thing I want to discuss with you is how long do your chemical leaveners last? Baking powder and baking soda. How long should you keep them? Hopefully you're keeping them in a cool, dry spot in a cabinet. You don't want to keep them out on a shelf where the sun is shining, and you don't want to keep them where it's very humid. They will react and they will not last as long. For the most part, there's an expiration date on all chemical leaveners, and you can read it on the side of the package. But you really want to get the longest shelf life you can. And sometimes you can push it a little and get beyond the shelf life. How do you prove that your baking powder and baking soda work? So let me give you two really very easy ways to tell. Number one, baking soda. So we know baking soda needs an acid and it needs moisture. So if you take a teaspoon of baking soda, you're not sure if it's active or not, you want to put it into a glass, add a little vinegar. If you get foaming, it's wonderful. It's active and lively and you can use it. It's perfect. Baking powder. If you take some baking powder and put a little boiling water, remember baking powder has it all. It has that acid and it has, it already has everything that it needs to rise on its own. So all you need is some boiling water. If it foams and fizzes, it's alive, it's active, and you can use it. It's not really alive, but it's active. So again, you want to store everything chemical leavener-wise in a airtight, dark area in your kitchen. And that's it. I mean, that is a very, very easy way to understand chemical leaveners. And if you've enjoyed the episode today, hit the subscribe button. And if you'd like to leave a review, I would greatly appreciate it. If you have any questions, head on over to bakingradio.com and leave me a message. I would love to answer some of your questions on air. And on the next show, we're going to be discussing cookie characteristics and how to manipulate them.